Not too challenging, but there are some new ideas here. The stuff we did yesterday hopefully is pretty easy. So this is what we looked at yesterday. We were looking at composite functions, and we worked with a couple functions, and we added, subtracted, multiplied, and divided them, and we were talking about domain issues and stuff. So this example here, we've got this simple function like the square root. And this simple function, 2x minus 8, just a regular old linear function, and we added, subtracted, multiplied, and divided those. Talked about the domain for each one, and then we talked about these guys right here. So a little more complicated functions, especially this one right here. So we took f of x, and we divided it by h of x. And h of x had its own issues. Okay, you couldn't plug in a positive 3 into that. So when we take these and divide them, we get 3x plus 4 divided by x over x minus 3. That's a complex fraction, so I crossed that off, flipped it over, and multiplied, and we ended up with this expression right here. And then when you look at this guy right here, you say, well, wait a minute, there's something else we can't plug in. Besides that original number of 3 that was a problem with the domain, once we simplify it, we see we can't plug in a 0 either. Okay? So 0 is not a problem in f, and 0 is not a problem in h, but once we divide them, 0 is a problem. So we've introduced one of those domain issues. Okay? Any questions there? Okay, that's the type of thinking that we've got to realize is going on when we're dealing with these composite functions which are coming up. So just a quick review of what we did yesterday. We've got a couple more functions. We want to figure out what f plus g, f minus g, f times g, f divided by g, and we want to figure out the domain for each of them. Okay, now in general what I said was you take the smallest domain. So on this problem up here, this one has a domain, square root, all positive numbers and 0, so anything that's not negative, and this one has all reals. But you'll notice that the domain for each one of these was just the positives. Okay, and then we had that issue with 4 once we divide. Okay, so let's see. It says find the following and state the domain for each. So this one is just going to be the square root of x plus 1 plus 2 over x. That's it, but the tough part is figuring out the domain. So I'm going to blow this up just a little bit. What's the domain for this one? Anything that is bigger than negative 1. Greater than or equal to negative 1. So the domain on this one is from negative 1 to infinity. Because it's okay to plug in a negative 1. You get negative 1 plus 1. That's 0. Square root of 0 is 0. That's totally okay. And what's the domain for this one? Okay. Anything as long as it's not equal to 0, right? So if we put the two of these together, it's kind of like we put their restrictions together. You can't have anything less than negative 1, and you can't have 0 also. So we're going to say this. You can plug in anything you want as long as it's in that interval except for 0. Does that take care of everything there? Okay, what's the only difference between A and B? Yeah, it's just a minus. That's it. That is the only difference. So I'm going to write square root of x plus 1, and then I'm going to write minus 2 over x. What about the domain? Does the domain change? Nope, minus doesn't introduce any weird domain issues, so that's still going to be negative 1 to infinity as long as x is not equal to 0. Oops, that's looking ugly there. Okay, and then multiplication. This one's going to be square root x plus 1 times 2 over x. If we wanted to simplify it, I suppose we could write it this way. This probably would look the best. Domain. Same thing, okay? Same domain there. And then the last one, if we do f divided by g. So if I do f divided by g, now take a good look at this. This is going to be the square root of x plus 1 divided by 2 over x. Okay, now let's simplify. So I'm going to cross this off. I'm going to flip that over and multiply. So that's going to be, if If I simplify, I get x, square root x plus 1, divided by 2. What's the domain now? Still got the square root of x plus 1, so that's still going to be negative 1 to infinity. Do we still have the issue with 0?
No.
Is there a 0 in the denominator anymore? There's not. Okay, but here's the tricky part. Everybody listen, because this is going to be really important in just a second. You have to consider where this expression came from. Where it came from was right here. And could I plug a 0 into this denominator right here? I couldn't. So it doesn't matter how it gets simplified. You've got to consider, hey, where did these original things come from? If it was a problem starting off right here in g of x, it's still a problem in the end. So that's going to be x not equal to 0. Okay, same thing there. Okay, any questions? All right. Okay, let's talk about composite functions for a second. Okay, composite functions are a little bit more complicated than just combining functions by adding, subtracting, multiplying, or dividing. Okay, so composite functions are created when one function gets, we'll call it, plugged into another. So when we take one function and we plug it into another one. So if you take a look at this diagram over here, here's how a normal function works. We plug in a number, it does something to it, and what comes out is the function value at that number. Or we plug in an x, we get out an f of x. Okay, that's that function notation we were talking about. Okay, we plug in an x, we get out a y. We plug in an x, we get out an f of x. So if I dump in a 3, what comes out? F of 3. Okay, you don't even need to know what the function is, but we can still talk about it in terms of function notation. If I plug in a negative 2, what comes out? F of negative 2. Okay? So whatever I plug in, whatever I dump into this function, what comes out is f of whatever I dumped in. Okay? So if we plug g of x into the function, so if I plug in a 3, I get out f of 3. If I plug in a negative 2, I get out f of negative 2. If I plug in an x, I get f of x. What happens if I plug in a g of x? I get f of g of x, and that's what it looks like. Okay? See the nice uniformity here? Mathematicians like things that work consistently. They do the same thing every time. Okay? So when we plug g into f, what we get out is f of g of x. That's how we say that. F of g of x. Okay, now you might have seen this before. This is a common notation. Okay, I like this a lot better because it describes what's going on. Besides that, people usually see this and they say fog. That's no good. Okay, so they're both read the same way. F of g of x, f of g of x. They're both the same thing. Okay, the thing I like about describing it this way, using this notation, is you can literally see, hey, I took x and I plugged it into g, and then I took g of x and I plugged it into f. Okay, so it's kind of a three-step process. Okay, we're going to take x, plug it into g. What comes out is g of x, and then we're going to take that, plug it into f. Oops, and what comes out is f of g of x. Okay, all right. So let's take a look at this one here. On this example, it says almost any function that you know of can easily be written as a composite of two functions. So write h of x equals square root 2x minus 7 as a composite of the square root function and 2x minus 7. So the question there is, what got plugged into what? Did f get plugged into g, or did g get plugged into f? This got plugged into that. Because remember, when we're dealing with functions, whatever we're plugging in takes the place of x. So if we do f of g of x, okay, everybody watch please. Here's the function f. This is kind of like the outside function. The function f is the square root function. So I'm going to draw a big square root. Now what I'm plugging into that square root is g of x. And g of x is 2x minus 7. Does that make sense? So we're literally taking one function and plugging it into the other one. And if there's more than one x in the function, it gets plugged in every single place there's an x. Okay? All right, go ahead and flip the page over. So we're going to start off by finding some function values, some composite function values at specific numbers. So this is read f of g of x. So we're going to plug in a 4. So we're going to take a specific number. We're not going to talk theoretically or anything. We're just going to take that number and we're going to plug it in. My question for you is, what do we plug it into first? Do we plug it into g or do we plug it into f? We plug it into g first. And this is why I like this notation again. That's what it means. We're going to take 4, we're going to plug it into g. What comes out is g of 4. Then we're going to take that answer, plug it into f, and what comes out is f of g of 4. Okay? So let's figure out what we've got. We're going to take 4 and we're going to plug it into g. What number comes out when we plug in a 4 into g? 4 squared is 16. 16 minus 1 is 15. That's the number that we get out. We're going to plug that into f. So, sorry, I said f, wrote a g. Okay? So we're going to plug a 15 in here. So this is going to be 2 over 15 minus 3. So that's going to be 2 over 12. So our answer is 1/6. That's our answer to that one. That is f of g of 4. Okay, let's find g of f of 2. Alex, what do we plug 2 into first? Yep. Is it g? This one here? Plug it into f. So we're going to take 2 and we're going to plug it into f. What comes out is f of 2, which is, plug in a 2, we get, well, is this going to be sticky? Hopefully not. It's not, is it? 2 over negative 1, so the answer is negative 2. So what comes out is a negative 2. And then I'm going to take that and I'm going to put it where? Put it into g. So I'm going to find g of negative 2. So that's going to be negative 2 squared minus 1. So this is 4 minus 1. The answer there is 3. Any questions? Okay. Somebody want to tell me what's going on with this one? This one's a little weird. Shane.
You are plugging it into itself.
Yep. So we're going to take 4. We're going to plug that into f. We're going to get an answer. Then we're going to take that answer and we're going to plug it right back into f. Okay? So we're going to find f of 4. So plug in a 4 into f. If you plug a 4 in, this is what you get. Let's see, 2 over 4 minus 3. That's going to be 2 over 1. So that's a 2. And then we take that and we plug it into f. So this is going to be 2 over 2 minus 3. So the answer is negative 2, isn't it? Overall, top's a 2, bottom's a negative 1. Everybody good with that? No questions? Okay. Would you find f of g of 2? F of g of 2. Okay, so I'm going to take a 2 and I'm going to plug it into g. Okay, so I need to find g of 2. And what comes out is, let's see, if I plug in a 2, 4 minus 3, so that's going to be 4 minus 1, 3. Answer that comes out is 3. And then I take that and I plug it into f, right? So I'm finding f of 3. And I heard some people whisper, what goes on with this one? Okay, this one is undefined, or we can say DNE. What did I say DNE stands for? If I told you that? Anybody know what DNE stands for? Does not exist. Okay, There's no function value there. Okay? Now, watch please. Is there a problem with plugging a 2 into this function right here? Okay, there's not, is there? Okay, but we didn't plug a 2 directly into f. What we did first was we plugged a 2 into g. Now, it's okay to plug a 2 into g, but then we're going to take that stuff and where are we going to put it? We're going to put it into f. So if you can't plug a 3 into f, what better not come out of g? You better not get a g out of, or a 3 out of g, because you're just going to plug it into f, and we know that doesn't work. Okay? All right. Okay, so let's take a look at the next couple problems. Okay? Is that pretty easy? Okay, good. All right, so we've got the square root, and we've got 3x minus 5, and we want to find f of g of x, and we want to state its domain. Okay, now, this is where you have to be pretty darn careful in thinking about, well, how do these functions relate to each other? If we're going to find f of g of x, so the first thing we're doing here is we're literally taking a function and plugging it into another function. We're not taking numbers and plugging them in anymore. We're taking functions, okay? Variables and all and stuff like that. So this is going to be, I'm going to take this function right here, g, and I'm going to plug it in right there. Because remember, f is a square root function, and what we're putting in there is 3x minus 5. Now, what is the domain for that function? Whatever this is, it better be, whoops, getting ahead of myself. It better be greater than or equal to 0, right? It's okay to take the square root of 0, but you can't take the square root of something that's negative. So we'll solve this. We'll add 5 to both sides. So we'll have 3x greater than or equal to 5. So we're going to have x greater than or equal to 5/3. So if we were to write it in interval notation, remember, if you wanted to graph this, here's 5/3. We'd circle that, and then we'd shade the greater than side. It would be over here. Would I fill in this circle? Do I fill that in?
Yeah.
You do fill that in, okay, because it can actually equal it. Okay, so it's okay to plug in 3/5. That's totally fine. So the domain is going to be from, 5/3. 5/3 to infinity. Okay, there's our domain. Okay, so let's talk about a general strategy. The easiest way to find the domain of a composite function, so actually writing down the function isn't terribly difficult. You plug one into the other and then you just simplify. Okay, finding the domain sometimes can be difficult, and that's what we're going to look at on this next one. So the first thing we do is assume you can plug in anything you want, because most functions that we deal with, they don't have domain issues, but assume you can plug in anything you want, so all real numbers. Throw out anything that is not in the domain of the inside function. Okay? So here was the inside function. Do we have to throw anything out of that? Nope. That's all real numbers. Okay? And then it says simplify the composite, then throw out anything that doesn't work in the simplified version. So here's the simplified version, and we know we can't take the square root of a negative, so we just figure out what the domain is based on what part is greater than or equal to 0. Okay? All right. So let's look at example 7. You have several of these on your assignment. It says find the domain of f of g of x. So here's the process. We're going to look at the inside function. Which is the inside on this one, f or g? G is. So let's look at this right here. Let's throw out anything we know doesn't work to begin with. So what doesn't work in here? Okay, so let's throw out a 0. Okay, we're going to keep that right here for the time being. Now let's go ahead and do the composite. F of g of x. That's going to be, f is 1 over something plus 3. And what is that something that I'm plugging in? Okay, it's going to be negative 2 over x. Okay? All right. And then we simplify. So let's go ahead and simplify this. So this is 1 over, so I'm going to write this as negative 2 over x plus 3. And then this is a complex fraction. Okay, there are several ways that we can deal with complex fractions. This is what I like to do because it's pretty easy to follow. I'm going to get a common denominator. I'm then going to write it as 1 over, this would be negative 2 plus 3x over x. And once I have a single fraction in the denominator, Remember, we never divide by a fraction. I'm going to take that and I'm going to flip it over and I'm going to multiply. So I'm going to multiply by x over negative 2 plus 3x. Any questions there? Gosh, so this just got really complicated really quickly. We're going over a bunch of fractions. We're talking about domain, how to simplify complex fractions and everything. So here's the simplified version. It's just x over. Now I'm going to write it this way. Is that okay? Does everybody agree that's probably the best way to write it? Okay, so here's the composite. So off to the side I'm going to say, hey, you wanted to know what f of g of x was? Here it is. It's x over 3x minus 2. And we already said we can't plug in a 0. We threw that out to start with because we started with g. Is there anything else in the simplified version that we need to throw out? It can't plug in, can't have the denominator equaling 2/3, and what would make 3x minus 2 equal to 2/3? Or sorry, equal to 0. Giving away the answer in the question. That's no good. Okay? So 2/3 wouldn't work, right? We'd have to throw that out. Is that all right?
Would also not be because f of x is.
Okay, so here's the interesting thing, and this is why I put this statement right here. Be sure to think about why the numbers that look like they should be okay need to be excluded from the domain. And John's question, why things that look like they ought to be excluded don't need to be excluded. So the domain for this one was everything except for 0, correct? Okay, I need everybody to watch and think for a second. What's not in the domain here? Negative 3, right? Okay, so 0, well that makes sense that that would show up here. But why not the negative 3? Why does that not show up here? Okay, because where do the numbers that we plug in here come from? They come from here. So what can't come out of here is this number right here. What can't come out of there is a negative 3. Okay? So watch. If I say negative 2 over x, if I don't want that to equal negative 3, guess what happens when I solve this? I'm going to multiply by x. That's going to be negative 2 equals negative 3x, and I'm going to divide by negative 3, so I get x equals 2/3. If you plug a 2/3 into this one, what comes out is a negative 3, and then where do we try and put it? We try and put it over here. That's why the 2/3 doesn't work. Okay, it kind of takes the place of the negative 3. Okay, plug in 2/3 here, you get out a negative 3, and then you try and plug it in there, and that's why it doesn't work. Okay, does that make sense? Pretty cool, huh? All right, maybe it's math cool, but not really cool. Okay, let's take a look at number 8. Okay, so these are the same ones that we were just dealing with. It wants us to find each one of these, and it wants us to state what the domain is. So again, I'll run through this process. The first thing we do is we'd look at what we're starting with. If we're going to find f of g, g is the one we're starting with. So I'm going to throw out a 0. I'm then going to plug the g into the f. So this was 1 over negative 2 over x plus 3. I got a common denominator. Negative 2x plus, or negative 2 plus 3x over x. I flip that over and I multiply. So this is going to be x over 3x minus 2. So I get x over 3x minus 2. Okay, I'd circle that as the answer. I'd throw out the original thing that didn't work, and I'd add anything that I can't use here. And what I can't use here is 2/3. Okay, that's the process. That's about how quick it is if you follow. Up here above, I just did the same problem, but we kind of thought our way through and showed all our work on that one. Okay, but that's how you do it. Okay, so that's the first part of the problem. So let's do this one. G of f of x. What one are we starting with? Starting with f. Okay, again, it's kind of the opposite order. We're starting with f. It literally means g of f of x. So you start with the inside function. Okay, what do I need to throw out immediately? I need to throw out a negative 3. So that's not going to work. All right? Okay, Now let's plug this one into that one. So this is negative 2 over something. And what is that something that I'm plugging in? 1 over x plus 3. Well, look how cool this is. It's already a simplified complex fraction. All we need to do is flip that bottom over and multiply. So this is going to be x plus 3 over 1. So the simplified version is negative 2x minus 6. There is the simplified version. Now let's write down the domain. The domain is, you can't have it equal negative 3, and is there anything else that we need to throw out? Look at this simplified version. Anything else? Is there any division? Nope. Any square roots? Nope. Any logarithms? Nope. Nothing else we have to throw out. Okay? So that's it. This would be it. There's the domain. There's the simplified version. Now, what's the number that we can't plug into this? 0, right? You can't plug in a 0. Where do the numbers that we plug into this come from? They come from the 1 over x plus 3. Is that ever going to equal 0? Okay, listen please. Okay, if you've tuned out, please don't. This is going to come up again and it's going to bite you. If you're dealing with a fraction, the only way a fraction can equal 0 is if the numerator equals 0. It doesn't matter how ugly the denominator is. The only part that can make the whole thing equal to 0 is the numerator. Because remember, the denominator can't be 0, otherwise it's undefined. So the only way this could be 0 is if 1 is equal to 0. Does 1 ever equal 0? Nope, so we don't have to throw anything else out. You never get a 0 out of this one, so you can plug in anything except for negative 3. Questions there? Sure? If not, we're in pretty good shape then. F of f. What do I throw out to begin with? Throw out a negative 3. Then the rule is 1 over something plus 3. And what am I plugging in? 1 over x plus 3. I'm plugging f into f. And now I need to simplify. Okay, so I'm going to blow this up a little bit. That's a little too much. That's excessive. Okay, so I need, let's see, a common denominator, so I'm going to multiply the top and bottom by x plus 3. So this is going to give me 1 over x plus 3 plus 3x plus 9 over x plus 3, which is 1 over, this would be 3x plus 10 over x plus 3. We good with that? Okay, I can now take that and I can flip it over and I can multiply. So we're going to multiply by, cross this out, x plus 3, 3x plus 10. So the simplified version of that f of f rule, that composite function, is x plus 3, 3x plus 10. That is the simplified version. What is the domain? We already know we have to throw out one thing. What was the one thing we already threw out? Negative 3. Is there anything else we need to throw out? Look in the simplified version. What would make this equal to 0? Negative 10 thirds. You got to throw out negative 10 thirds. Okay? Any questions? We said negative 10 thirds, right? No, it was 3x plus 9 and then we had 1 over here, so it's 3x plus 10. Okay, good question. Anything else? Okay, watch, you don't have to do this. I just want you to watch. Okay, what would happen if I plug in a negative 10 thirds here? Okay, just watch. This is going to be 1 over negative 10 thirds plus 3. So that's going to be 1 over negative 10 thirds plus 9 thirds. That's going to be 1 over, well, if I have negative 10 thirds plus 9 thirds, that's negative 1 third. If I flip that over, that's going to be negative 3. What do I try and do with that then? I try and plug it back in. And look, a negative 3 plugged in there makes that undefined. Okay? That's why it shows up that way. Okay, any questions? Okay, this one's pretty easy. G of G. Okay, what do I need to throw out to begin with? 0. G is the rule -2 over whatever I'm plugging in, and what are we plugging in? -2 over x. Okay, these are actually kind of nice the way this works out, because this is already a complex fraction. I can just flip that over and multiply. So this is going to be a x over a -2. So well, holy cow, take a look at this. Doesn't the -2 cancel with the -2? The rule is x. So my answer, my simplified function is x. Do I need to throw anything else out other than 0? Nope, because there's no division here. We didn't introduce anything weird. Okay. Okay. Questions? Okay. All right. Last couple. This one's going to be pretty easy, and this one's just kind of interesting. Okay. If you get how to do this algebraically, like we've been doing, here we're going to do these graphically. So this one says, find functions f and g so that f of g equals h. So look at this and figure out what functions are there in this problem. And there's more than one answer to this, but in the big picture, can somebody tell me what functions are involved here? F and G, H. Okay, in terms of, think about the functions that we've dealt with. Square roots, linear functions, quadratics, squaring, cubing, raising to a power, stuff like that. The functions that are involved in this one are, the easiest way to look at it would be, I've got something to the 4th power, and I've got 2x plus 3. So if I take this and plug it into that one, wouldn't that produce this guy right here? So if I called this f and I called this one g, if I did f of g of x, wouldn't that produce the h that we're interested in here? Okay, so the easiest way to answer this is, let's say f of x is x to the 4th, and let's say g of x is 2x plus 3. That would work just fine. That's one answer. Okay, any questions there? Yeah. There are different answers. We're going to go over one of them right now. Okay, let's say I said f was that. What would g have to be to get it to work out to be this guy right here? I'm going to take whatever I have here and I'm going to plug it in right there. How do I make it end up to look like 2x plus 3? What would g have to be? It would have to be 2x. Okay, now that's not the most straightforward way to do it, but that's not bad. Okay, do you want to see this is the cop-out way to do it. You want to see this? F of x equals 2x plus 3 to the 4th. And g of x would have to be, not 1, x. Okay, that's a cop-out. Don't do that on a test. Got it? But it's still a composite, isn't it? Because if you plug this in there, you do get that end result. So that would be okay. I like those other two much better. Okay, last problem. Okay, any questions before we do the last one? Can I enlarge this so we can just see the last problem? Okay. All right. So here's what we want to do on these problems. It says evaluate each expression using the graph. So we're going to start by plugging in a -1. That is the x. So we go to -1 and we want to figure out first what is f of -1. So let's see. This is f, the V-shaped graph is f, and the squiggly one is g. So if I start here, what's the function value there? 1. I then take that 1 and what do I do with it? I plug it into g, or in other words, it becomes the new x. So that means I'm going to transfer the one that was a y, and we're going to make it an x, and I'm going to figure out what the function value is on G. So what's the answer to this one? The answer to this one is 4. Take a good look at that. We're just going to do a couple more. You've got a problem on your assignment like this? Any questions? Let's do the same thing again. I'm going to plug in a 0, and what comes out is 0. So this is like finding G of 0. If I plug a 0 into G, what's the function value? 1, 2, 3, 4, looks like 5 to me. Is that okay? Does everybody see that? Plug a 0 into F, you get 0. Take that 0, plug it into G, and you get 5. Okay, let's figure out what G of negative 1 is. G of negative 1 is right here. So that's going to be 3. So now I figure out what F of 3 is. So I'm going to change this y coordinate, I'm going to make it an x, and I'm going to figure out what F of 3 is. So F is the V-shaped graph. So what would the function value be there? Negative 1. Okay? Okay, would you do D and E, check with your neighbors, see if you got the right answer, or see if you got the same answer, and figure out if it is indeed the right one? Check with your neighbor. They're not going to bite. They might yell at you, but they won't bite. G of 4 is 2. Then we take that 2 and we plug it in for the new x on F. So we're going to go to 2 and we're going to plug it into F. That's down here. What's the answer? Negative 2. That is the correct answer. Okay, I'm going to do this one just by looking at the graph. So I'm going to take 2, I'm going to plug it into F. So that is an x value. I'm going to go to 2, and I'm going to figure out what the function value is at 2. At 2, it's negative 2. Right? So then I'm going to trade that. That's going to be my new x value that I plug in. So I go to negative 2, and what function am I trying to find the function value on, G or F? On G, is there a function value here? So this one does not exist. Does not exist. There is no function value there. Okay, so we wouldn't put any specific number like 0 or anything like that. We just say it doesn't exist. Okay, questions? All right, you've got about 10 minutes to work right now. There's the assignment. It's on page 262. So if you go ahead and get that out and get started, I'd appreciate it. If you've got questions, please holler. Sam, I promise not to leave the room until you're done with all your questions.